Hello, my name is Sridharma Vijayan. I manage TidyB sales for India. I've been an ex-AWS guy as well for 7 years. Before that, I was in Microsoft for 12 years. All this while doing multiple roles, okay, technology, sales. Now I'm into full-time sales. So I'm here to talk about TidyB. How many of you knows what is TidyB? Anybody? Nobody knows. Okay. So TidyB is a distributed database. Okay. Distributed databases solves a lot of challenges faced by the single server architecture databases like MySQL. So why we are based out of, made out of MySQL is because our founders were MySQL DBAs. They faced a lot of challenges on the single server architecture when the scale happens. That's when they decided to create their own version of MySQL compliant database. And they put it onto open source community, and it became very famous there in the community. Then there were a lot of corporates who were interested in TidyB, and they started using us, and then we had to come out with support levels. Till now we are an open source database. So what are the typical challenges which a single server architecture, if you're going to deploy it or if you already have? They have challenges around how will the data scale? Because a single server architecture means on a single server you have computation and storage, everything on one single server. There is a bottleneck there, right? Because what if you want to just, if there are a lot of reads coming into the database, right? Or there are a lot of writes coming into database. You have to install, maybe you can do a vertical scaling. Maybe increase the processing power, maybe increase the database, maybe the data storage size, but still the bottleneck exists, right? After that, you might install one more server, maybe, and do a sharding. I hope some people know what is sharding, right? This is a typical MySQL server architecture, okay, single server architecture. If you see users, application, backend. MySQL has got computation and storage in the same layer. And I put a red triangle, it's because there is a bottleneck there, because when you vertically scale it, you cannot go beyond the limitation of hardware. That's when you go and create, say, another server, DB1, DB2, DB2, DB3. But it's okay to create another one, but how would you connect them? Use something called manual sharding. And sharding has got sharding keys. So when you're doing that, what happens is that, it takes a lot of resources. It takes a DBA's life out. Sometimes it must never work. And there is downtime as well. So it is not very reliant, right? So that is when, like say, take a customer, like any e-com customer. Maybe they have a Diwali sale going on. Only for that period they have to scale. Then they have to come down. What will happen? You already scaled up to multiple servers. Can you go back? Then again you have to reshard it, and use the sharding key again. So these are the typical challenges which a single server architecture databases face. I'm not saying that MySQL is a bad server. It's an excellent server if you have data size below 300 to 400 GB. Super. It's very fast. Single server architecture can handle it. But only thing when the scale happens is where the challenge starts. Otherwise, that's why people move into distributed databases. This is a typical architecture of one of our clients, which is an e-com client. So what they had a master server. They had a hot standby server. Since e-com means, read requests are extremely high. Right? If a new phone launches, everybody will be just reading the data, right? So they had a read replica as well to fasten it, okay? And that was one shard, second shard, third shard. They kept on increasing as the scale goes up. Maybe 10,000 users become 1 lakh users, that is scale, right? Then what will happen? You need replication because you need a backup copy. What if that goes down? That also has to be sharded. Replica 1, read replica 1, hot standby. And the story goes on. It goes on and on and on. The same server, the same client went up to 900 servers, okay? That's when they decided they have to move to a distributed database for scale. Because this is not going to work. You cannot keep on adding servers. When you can keep on adding servers, but you have to do sharding, right? What happens if the sharding logic breaks in between? Then Yeah, those who are DBAs will know it's a pain. That's when they decided to look at distributed databases. There are a lot of players in distributed database, but TidyB stands a little different from them, which I will tell you. That's what comes, okay. This is supposed to be intro, okay. So TidyB has been the chosen database for a very long time now because we've been getting awards, left, right, center. Everybody's saying that we are the #1 fastest growing database in the world, which also is because of the adoption that we have. I think a week back, Uber decided to move to TidyB. Okay, the entire Uber operation is going to move to TidyB because of the scale, right? Anything where there are a lot of users going to access, that's where TidyB fits in perfectly. Right? If there is a predictable workload, you don't need a distributed database. You can have a single server architecture and be happy. But that's where TidyB is growing really fast. We got some major customers like Airbnb. We got Flipkart here. I don't know whether I can say the name. Okay, Delivery. Then we have here Airbnb, Samsung, Visa, Binance. We even have DeepSeek. DeepSeek is running on TidyB, okay? So these are some of the clients where the scale is there. How are we different, right? What are we doing? It's like, it's not a magic, it's the architecture. So if you see the single server architecture, which I showed, it's like this, right? It's a lot of complex components and multiple servers and sharding and key and yeah, a lot of things, okay? So as I said, distributed server means it is distributed across multiple servers. It is, that's why if you look at the cost, it will be a little bit more because you're talking about 5 servers here. 5 minimum servers, okay? Otherwise it won't work, okay? It will work with 2, but there's no fault tolerance then. So application users again, to the application layer, there can be load sharing there, load balancing there. And we have got 3 major components inside the TidyB architecture. First is the computation layer, which is TidyB layer. And then we have PD, and then we have the storage cluster. These are the 3 layers. If you see in a single server architecture, all 3 on one single server, right? And then you replicate it. Here, we have, you say like, I'm removing the processor out and putting it separately, and hard disk out and putting it separately, and I'm going to upgrade it, right? So here what it happens, even the computation layer, it is fault tolerant. Suppose, what is the need? TidyB is basically, TidyB inside the TidyB architecture is the computation layer. It is a stateless server, there is no storage. It is only meant for processing queries. If a MySQL query or compatible query comes, it understands that and it forwards to the right place, okay? So, say if as an e-com company or a delivery or a logistics company, if the requests are coming very high, there's nobody writing onto the storage side. It's only they have to address the queries very fast, right? That's when on the computation side, they have to increase the processing power or they can increase the number of servers when the scale happens. And this has got auto scaling, auto sharding, sorry. Auto sharding is built into this. You don't have to do a sharding key or something. You just add a server, when the scale goes down, you can just remove it, it's done. And it is fault tolerant, which means there is actually 3 servers are minimum required. There are 3 copies of data residing in all of these servers. So even if one goes down, the other 2 will take care of till the time you can put in the another server as a backup, okay? Then we have the PD server. On the cloud, it is not existent. Only on the on-premise, it is there. PD is basically the brain of TidyB. It knows where to store data, where to read from, what kind of data is coming inside, which server to be upgraded as the master server, which server to be degraded as the slave. All this decided by PD. Even that is fault tolerant. And that is also stateless. There is no hard disk, there is no storage. It is only for computation processing, okay? Then comes the storage layer where we have 2 products inside, which is called TiKV and TiFlash. Basically, TiKV is a OLTP server for transactional data. It stores transactional data, which is like any other database. And that is also fault tolerant. 3 servers are there. And then we have TiFlash, which is an OLAP server for analytics. Usually if you have a MySQL customer, you might have Snowflake as your analytical software. You need to write a code to redirect it to the analytics server to get the dashboards and reports. Here everything is in one single server. I'm not saying that it's the same as Snowflake, okay? It is a transactional analytical server, which means day-to-day analytics. So if somebody is selling phones, I want to know which phone is selling more today. you can get the analytics reports, transaction analytics. Delivery is our customer. Delivery uses it for monitoring where the truck drivers and where the courier guy has reached. They need to know a dashboard of where the big couriers are going. Okay, so those kind of transactional analytics, not for historical analytics. It doesn't mean that it can do historical analytics, it can do, but there will be storage coming in, it will take a lot of money, okay? So these are the three components. What happens is that if suppose a request is coming to read or write a 10 MB file, which comes from the application layer, TidyB understands that it is a transactional data, it is not analytical data, it sends it to PD. PD says that, okay, TiKV2 is free. I'll first copy will be on TiKV2, then 1 and 3 will be backup copies. So 10 MB of file will be cut into maybe 256 KB of chunks and stored based on election, every piece. Which means, at any point of time, all three servers will have a copy of the entire database. And when scale happens, you can, if there is a lot of writes, there are a lot of companies who writes a lot of data into it, right? You can increase the number of TiKV. Just add one TiKV server, it will be automatically added to the shard. It is auto sharding, right? Same is the case with TiFlash. So TiFlash is an OLAP server for analytics. So basically what is TidyB? TidyB is a OLTP server, it is an OLAP server, and it is a HTAP server. HTAP is hybrid transactional and analytical processing server. What it means, it's a word, right? So why we call it as a HTAP server is because any request coming in, it can be analytical server, it can be a transactional request coming in. PD knows that it is an analytical workload. So then it redirects directly to TiFlash. There is no coding required, whether it is an OLAP or whether it's a transactional data coming in or analytical data coming in. It notes and it will automatically do it. So that's why it is called as a HTAP, hybrid transactional analytical processing. On top of that, one more thing we have added, which is vector compliant as well. For any AI indexing database, you can use the TidyB, same server. It accepts AI workloads as well. So it's basically an OLTP, OLAP, HTAP, and a vector. So all these functions are there. And we are open source, okay? You can just start download and start using it. But I won't come, I'll come only for the cloud sales, okay? Okay? So just to show you that what we have got horizontal scaling. As I said, by default, the architecture is meant for horizontal scaling. And it gives high availability because again, the architecture is like that, right? There are 3 servers there. It's already highly available. You don't need to spend any money on that, right? Then it can contain mixed workloads because it can have transactional data as well as analytical data as well as maybe a AI data, right? And MySQL compatibility. So those who have MySQL server or any MySQL compatible server, it is lift and shift to TidyB. There is no code change required. Developers don't need to change or learn anything new. It is the same. You know MySQL, you can do. But we are not MySQL, okay? We are just, MySQL can be version 5, 6, 10. We are just a compatible server, okay? Then multi-cloud, yeah. We go there on almost all the clouds, okay? You name it is there. And we are open source because, as I said, our history is tied towards open source. We are always an open source company. That will never change. We have given the source code of TiKV and TidyB to open source. That means it is gone. Okay? So we cannot one day say that we are by open source, we are going commercial, you have to pay us. We can't do that. Okay? Then robust security. We got end-to-end security. We are compliant with almost all the compliance standards in the world because we have to. When you are in a software as a service under AWS or any other cloud platform, you have to be 100% compliant with all the compliance standards. Like HIPAA, maybe ISO 9002, maybe SOX compliance, GDPR compliance, we have to, okay? If there is anything which is not there, we can get it customized for you. And this is one of the use cases, I don't know whether I can show it, it's like Karth's use case, okay? And yeah, this is the example of the TidyB AI, the data which goes in, it is there, people are using it, they don't need. So the typical scenario is like you have one server for transaction data, one for analytical data, one for AI data, and then you go in the circle, right? Which is not required. You just have one single architecture, everything will hold in that. And what are the benefits which customer tell us is that there are two key benefits on this. It is not all good. Okay, there are some points, negative points as well. What happens here? There are 3 storage servers. If you have 1 TB of data, which means you will have 3 TB of data in TiDB. It is expensive, right? So how do we address that? That we are addressing by the way of compression. We have compression, we give you the option of selecting the compression algorithm right from 20 to 60% compression. So by default you will get 60, okay? But if you want certain files you think that the compression ratios won't match, you can go with the, whatever the algorithm you want, you have got the option of selecting that. So we get around 60% compression, so that's way you can reduce the cost of storage, but it doesn't, you cannot compare it with the single server architecture. It is what it is, okay? So the customers moving to us, basically, over a period of time, I met so many customers, why they moved. They come out with 2 main things. First is on the database consolidation. Usually on the MySQL side, you have an application, you have a backend database, you have another application, another MySQL database, or another database. So if you have 10 applications, you have 10 databases running. Here, TiDB's architecture is not dependent on any application. You can have any number of applications connecting to the same TiDB cluster. That is called database consolidation. You can have. So indirectly you're saving money on running multiple servers, different databases, posted in TiDB, you get it everything under one. Management is simple. Secondly, on the compression, as I said, 60% compression will save you a lot of money. But still there are issues, right? If you see, this storage is the issue, right? Storage is always, you can't blame the cloud vendor for that. Its storage is it's a little expensive, right? Which means you're storing a 1 TB on a GP2, it will be expensive. So what happens there? That's when we have come out with TiDB X. Okay, that is the version which is currently running. We just launched, okay? What we do is that we segregate cold storage and warm storage. Cold storage is something which is historical in nature. Maybe historical purchase records, like I bought a phone 1 year back, I want to know, I want to see my invoice. How many times will I do that, right? I'm ready to wait if it's low. But if a new phone comes out, I want to see it immediately. If I don't see it, I'll go to the other vendor and buy it, right? So that is the difference between the cold and hot, or cold and warm data, right? So warm data will be, you can keep a timing of 1 day, you can keep the warm data in, and anything beyond 1, you can move to the cold storage, it will move to S3, which is the cheaper storage. But if you're looking at the warm storage, it will be like 1 millisecond response time, that will be like 3 millisecond response time. I think you can wait for that because it's a historical data, right? So that are the challenges which has been addressed by the latest TiDB X, which is called X, because we are 10th year. Anything else? Yeah, this is just an example of how we auto scale. When the data is going, you have number of servers are less. When the data grows, you have automatically it is scaling up, okay? And same with when short-term surges, right? Morning you will have big spike, afternoon you don't have anything. You will be hosting a lot of servers, and by the time they are now load, then what will happen, right? You need auto scaling facility. So as the load goes up, it will increase the number of servers, and it goes down, it just reduces it when the load is gone, right? That's why you have 2 products on AWS. So we have got TiDB Cloud Dedicated. All the 5 servers you saw, all 5 servers comes under a dedicated plan. That is for customers who know about predictable workloads. Like I know that during this time, my load I have to increase, so that database has to be a predictable workload. But there are unpredictable workloads, like morning it will spike up, afternoon there will be nothing, night 11 o'clock it might spike up, right? How will I go and auto scale and configure auto scaling, right? So that is where we have got TiDB Cloud Serverless. Serverless is again X now, it is starter edition. So this will auto scale, and it is pay as you go. You don't need to configure those 5 servers which I said, TiKV, TiDB, and TiFlash, and PD and all. This is just maybe 1000 QPS I have. I based on the QPS I charge. Although if there is no usage, then it is free. Anyway, it's free, okay, 5 GB is free. So anything beyond that, you can go and. So these are the 2 things which are there. It's both available on AWS Marketplace. It runs on AWS data centers. And if you want the demo, you can just go to tidbcloud.com, create an account, just use your Google ID, just click on it. I think it takes just less than a minute to configure all the TidyB Cloud Serverless. Okay, we get a 5 GB database free. If you want the on-prem one, it is there, tidyb.com. You can download the source code from there. You can start using it. If you want the commercial one, please contact me there. Okay, I'm there. Okay. And these are some of the customers that we have. As I said, we have got Airbnb, LinkedIn, we got Uber is adding on to that. We got Binance, and these are the customers that we have currently. These are the customers who was given us permission to put their logo. Okay, we got a lot of customers who don't give permission. Okay, because they learn multiple databases. They don't want to show that I'm close to only TidyB. That's why. I don't have a demo. I'm so sorry. Just go to tidybcloud.com and see the demo. Yeah. We have a stall here. If you want to know anything more, please let me come join me there. I'll answer some queries. Yeah.